By the beginning of the Cambrian period, competition for a place at the top of the food pyramid intensified in the seas and oceans. This triggered the so-called Cambrian explosion. Living organisms began to acquire the most diverse and sometimes very bizarre forms. Many of them acquired powerful chin-tin armor. Others learned how to disguise themselves. But, as in any era, predators became the main characters. Dinocarids were the thunderstorm of the underwater world of that time, the most famous representative of which was the Anomalocaris. Subscribe to the channel Age of Dinosaurs. From our videos, you can learn a lot of interesting facts about extinct and modern animals. By commenting on our releases and liking them, you will help spread this content to a larger audience. Dinocarids, or terrible shrimp, until recently were considered the ancestor of arthropods. But now most scientists agree that this is not the case, and these strange creatures also have nothing to do with shrimp. There is practically no information about the real ancestors of Dinocarids. Most animals of the Precambrian period were soft-bodied. Finding their remains or any of their traces is very difficult. It is even more difficult to correctly identify and describe these finds. Most likely, their ancestor were annelids. Just over 500 million years ago, some of them decided that it would be more convenient to move around with the help of jointed limbs. Other annelids have acquired functional swimming devices. It was these swimmers who became the Dinocarids, the main predators of the Cambrian seas. For 10 million years, representatives of this class of animals occupied the upper steps of the food pyramid. They were the perfect hunters of their time. Terrible shrimp had excellent eyesight, moved quickly in the water, and were the largest animals of the Cambrian period. The most famous representative of the class of Dinocarids was the Anomalocaris, or abnormal shrimp. The period of its existence is determined by scientists between 520 to 535 million years ago. Until recently, it was believed that this super predator of the Cambrian period would grow up to 1 meter in length. But recent research has shown that it could hardly be longer than 38 to 40 centimeters. Even such dimensions made Anomalocaris one of the largest animals of its time. Its body, covered with a laminar shell, was ideally suited for hunting the inhabitants of the ocean floor. For swimming, he used special mechanisms similar in the structure of the parapodia, paired fleshy outgrowths characteristic of bristle annelids. In Anomalocaris, these outgrowths were transformed into flat lobes. One of them was located a little lower and was slightly shifted back. It covered the gaps between adjacent elements of the top row. The lobe, which were located on segments close to the tail, were not preserved in almost any of the fossilized Anomalocaris found. Scientists have no doubt that this predator had no less than 11 pairs of blades. Recent studies report 13 paired lobes on the trunk segments and 3 on the cervical. With the help of wave-like movements of such blades, which formed a kind of fin on both sides of the body, Anomalocaris could develop a great speed. Also, the stability of the swimming was provided by a wide fan-shaped tail. Scientists believe that with such a body structure, Anomalocaris should have had problems with maneuvering. One study even built a working model. The result of this study showed that it is not required to have a highly developed brain to control such a mechanism. The adaptations available to Anomalocaris ensured the stability of the organism in water without the additional control from the nervous system. The mouth apparatus of all radiodonts, to which Anomalocaris belongs, is also distinguished by an extremely unusual structure. Animals from this order lack teeth, and modified limbs act as jaws. They are small processes that can hold food and direct it to the mouth opening. Anomalocaris had 2 frontal appendages that could reach 18 centimeters in length. In different species of Anomalocaris, These appendages differed slightly in structure, but they all consisted of 14 segments. Each segment was equipped with a spike called endite. The endite itself, approximately in the middle, could branch into several small spines. The mouth cone had a round shape and was divided into 3 segments using large rigid plates. Each sector consisted of 3 to 4 smaller plates, to which in between there were even smaller plates with a wrinkled surface. Such a ring, similar to a pineapple in a section, was able to contract and stretch, drawing the prey inward. Anomalocaris breathe with the help of primitive gills. In their structure, they resembled thin threads, turning into lanceolate and matriculate lobes. An important adaptation that helped this ancient predator in hunting was a unique eye. Anomalocaris' eyes were spherical and faceted. Their diameter was about 4 centimeters. They consisted of 24,000 tiny lenses. This structure made it the most vigilant invertebrate animal. For comparison, the eye of the modern fly consists of only 4,000 elements. With such vision, the predator could see any prey, even in muddy water. It is believed that trilobites form the basis of the Anomalocaris diet. But given the structure of the oral apparatus of these animals, many scientists question this theory. Trilobite shells were quite hard, and among the fossils found, no traces of contact of the mouth cone of the Anomalocaris with hard objects were found. Although some of the found shells of trilobites have similar traces, some researchers suggest that with the help of their frontal appendages, Anomalocaris could hold and swing the victim from side to side. Due to the resulting tension, the segments of the shell were separated from each other, and the victim's body was simply torn in half. So the predator got access to soft internal tissues. Not only Anomalocaris had such an unusual structure, other Dinocarids were also predators and obtained their food using similar adaptations. Living approximately 508 million years ago, the Cambreraster had a flat shape and a length of about 30 centimeters. His eyes were located on the upper side of the shell. Small appendages were located on the underside of the body. The distance between them was no more than a millimeter. It is assumed that with their help, he sifted the bottom soil, looking for small animals. One of the closest relatives of Anomalocaris, Herdia victoria, in addition to a segmented shell that protects the soft tissues of the body, had additional protection for the head. This peculiar visor consisted of 3 large elements, but inside this structure was empty. No vital organs were placed underneath it. The only reasonable explanation for the presence of this tool was it was needed to plow the soil in search of prey. Opabenia was very tiny compared to the rest of her relatives. Its length was no more than 7 centimeters. This predator, who lived about 505 million years ago, is remarkable for its unusual adaptation for capturing prey. For this, Opabenia used a single process of great length. At the end of such a primitive tentacle was a rather impressive grasping claw. Due to the small amount of object information about animals that inhabited the planet more than 500 million years ago, it is almost impossible to trace the relationship of dinocarids and anthropods. In such cases, scientists try to detect at least a transitional form or similar creatures that lived at the same time as the object of study. In the case of the development of the terrible shrimp, such as the creature found, it turned out to be a Calensia, an animal that combined the features of anthropods and dinocarids. It was equipped with both primitive fins, like those of the Anomalocaris, and small jointed legs along the entire body. Scientists suggest that this creature could choose which way was more convenient for him to move. The most formidable predators of the Paleozoic era are without a doubt scorpions. These giant anthropods have been at the very top of the food pyramid for more than 200 million years. And only the Permian extinction did not allow them to conquer not only the seas and oceans, but also the land. Today, we will talk about how such a bizarre life form appeared and what type of crustacean scorpions inhabited our planet in different periods. It is correct to call these animals similar to monsters from science fiction films Eurypterids, and the colloquial English name sea scorpions and the Russian name cancerous scorpions are not correct from the point of view of science. Also, these names do not in any way reflect the real origin of these predators. From Greek, the name of this detachment can be translated as broad wing. It is due to the unusual structure of the hind part of the limbs of these animals, but cancerous scorpions sounds more understandable and familiar to most viewers. Therefore, we will continue to call Eurypterids crustaceans. Eurypterids appeared in the seas of the Ordovician period, approximately 467 million years ago, and about 251 million years ago. As a result of the Permian extinction, all marine crustaceans disappeared. Only their descendants, who settled on land in advance, were able to survive this cataclysm. The first scientific descriptions of these arthropods were made in the early 19th century. Since this period, scientists have discovered a large number of wide variety of cancer scorpions. The length of some of them exceeded 2.5 meters. Others were approximately waist high to an adult. The smallest representative of the order did not exceed 3 centimeters in length. Currently, more than 250 species of Eurypterids are known. All scorpion cancers had a similar structure. Their body was protected by a powerful chitinous shell. The cephalothorax was covered with a large shield, and the tail had segmented armor. 6 pairs of limbs were attached to the cephalothorax, performing various functions. The first pair were movable claws. The next 4 pairs were intended for walking. The 6th pair of limbs had a flat shape and was intended for swimming. It was she who gave the name to the entire detachment. In the front of the head, there were 2 pairs of eyes. Large compound eyes were located on the sides of the cephalothorax. A pair of simple eyes was in front of the head. The segmented, movable tail gradually tapered. At its end, there was a sharp, elongated spike, or wide blade that worked like a fin. This body structure allowed crustaceans to both crawl along the bottom and swim. Most often, they moved in the bottom layers and also inhabited bays and estuaries. Late Eurypterids settled in freshwater bodies of water. Some of them could get to land for a short time. Already in the Ordovician period, crustaceans were divided into several families. Most species known to science belong to the Megalograptocea or Stylonurines. The earliest representative of Megalograptocea is considered to be the Pentacopter. Sea scorpions from this genus inhabited the world's oceans between 467 and 458 million years ago. According to researchers, their length could range from 75 to 170 centimeters. It is considered the largest scorpion cancer in its family. Scientists have a huge number of prints and fossils associated with this animal. Moreover, they all belong to individuals of different ages. This allowed the researchers to fairly fully recreate the appearance of the Pentacopter. His head shield had the shape of a trapezoid extended along the body. A pair of spines had been preserved on the 3rd subamere. Rear spine telson flat and elongated. Stylonurines of the Ordovician period are represented by the genus Brachyptera. This scorpion cancer was very tiny in size. The length of its body was no more than 7 centimeters. It lacked cheliceraal claws and swimming limbs. Its last pair of legs was located under the abdomen. Based on this body structure, scientists assumed that this creature moved exclusively along the bottom. At the same time, Brachypteris, like all other Eurypterids, was a predator. Scientists believed that it could lead the same lifestyle as modern cleaner shrimp. It is also believed that Brachypterans were parasites and lived off of large animals of the time. The Silurian and Devonian periods can be called the age of cancer scorpions. At this time, Eurypterids reached their greatest prosperity. A large number of species and genera appeared. Their shapes and sizes were very diverse. Cancer scorpions became the dominant creatures. In some fossils from the time, their remains account for up to 90% of all paleontological finds. The most common species is considered to be the Eurypteris, a small predator that gives its name to the entire order. Mostly, its remains are found in the seas surrounding the South American continent. At this time, very large scorpion cancers also appeared. One of these giants was the Acaterum, or Acaterimus, who lived approximately 409 to 422 million years ago. His remains are found in Canada, the USA, Russia, and the Czech Republic and Algeria. This indicates the widespread distribution of Acaterums. The largest representatives of this genus could grow more than 2 meters in length, while the smallest of them barely reached a couple of tens of centimeters. The chelicerae of giant crustacean scorpions from this order resembled the claws of modern crabs in structure, and its tail spike was flat and wide. Scientists suggest that the predator used it only for swimming. Most likely, these crustacean scorpions could not go on land. The Devonian extinction event affected many euryptid species. By the middle of the Devonian period, at least 10 families of this order disappeared from the face of the earth. But, on the other hand, it was at the beginning of the Devonian period that the largest crustacean scorpions appeared, among which we can highlight such a monster as Eurypterida. This crustacean is named in honor of its discoverer, paleontologist Otto Euckel. This predator could grow up to 233 to 260 centimeters in length. Fossils found in the United States and Germany range in an age of 406 to 410 million years ago. The grasping limbs of Eurypterida with claws were more than 45 centimeters long. Its prey included other invertebrates and various species of fish. It is believed that the Eurypterida was the closest living relative of Acateramma. Some scientists even suggest that it is the same animal. Significant differences between these species are found only in the structure of the cell array. They believe that the shape of the claws could have been influenced by lifestyle and habitat. Scientists find several explanations for the gigantic size of late scorpion cancers. It is believed that the size of arthropods is influenced by the weight of their shell. If you increase the armor in proportion to the size of the animal, then such armor will simply become unbearable. But the chitinous coating of the large Eurypterids is extremely thin. This allows the animal to maintain mobility despite its large size. A similar mechanism is observed in another giant representative of arthropods, the giant centipede, Anthropleura. It is believed that the main reason for the extinction of crustacean scorpions was competition from armored and then lobe-finned fish. By the beginning of the Carboniferous period, only 3 families of crustacean scorpions survived, and they all lived in fresh water. The most successful cancer scorpions of this period were Adelphalms. This family included 23 species. This represented almost 70% of all extant Eurypterids. Their remains are found almost all over the world, and the latest of them is about 283 million years old. This widespread occurrence of Adelophthalmos is associated with the next reapproachment of its continents. The land at that time was represented by one supercontinent, Pangaea. These last crustacean scorpions ranged in size from 5 to 32 centimeters and lived in shallow waters and coasts. By the end of the Permian period, not a single species of crustacean scorpion remained in the seas and oceans, as well as in fresh bodies of water. Only those species whose representatives moved to land in advance were able to continue existing. By the beginning of the Permian extinction, they could no longer be called crustacean scorpions. They gave rise to the development of new species of arthropods, which many became modern crayfish, crabs, and other animals known to us. Within 10 to 15 years after the extinction of the dinosaurs, many of the vacated ecological niches were occupied by mammals. In the middle of the Eocene, approximately 40 to 55 million years ago, a special family of predators, the Amphicyonids, originated in North America. To many lovers of paleontology, they are known as dog bears. Today, we will get to know these unusual animals closer. We will also talk about which of the modern predators are actually their close relatives. Subscribe to the channel Age of Dinosaurs. This will allow you to be the first to know about new publications. And your likes and comments will help in the development of the channel. It will also promote the video according to the algorithms of the site and will help expand its audience. A large number of species belong to the Amphicyonidae family. Some of them were small, others grew to the size of a modern polar bear. These animals got their nickname for their bizarre appearance. The first researchers of these predators could not come to a consensus regarding their classification. Someone attributed them to the ancestors of the wolf. Someone considered them to be primitive bears. All Amphicyons were characterized by the following features: a dog's head, the structure of paws, and the way of walking like bears, as well as a complete cat's body and long tail. By the late Oligocene, the diversity of dog bear species reached its peak. Further, the developmental paths of each individual family were finally divided. Amphicyons themselves died out, and their place was taken by the ancestors of modern dogs, cats, and bears. Each of them began to develop different features of the structure. This happened in the process of settling around the planet under the influence of changing living conditions. The ancestors of dog bears, and indeed of all predatory animals, are miacids. These small primitive predators appeared about 65 million years ago. This means that the first of them could well see the death of the last of the dinosaurs. In the Miacida family, there were animals that lived both on the ground and in the trees. Not a single species of these animals exceeded the size of a modern marten. They fed on insects, birds, lizards, and small mammals like shrews or opossums. The first Amphicyonids also did not differ in large sizes. It is noteworthy that they began their resettlement around the world from North America in a special way. In Europe, they ended up across the Atlantic Ocean. That is, dog bears did not cross the Bering Strait on a land bridge from Alaska to Chukotka. They sailed to the western islands of the European continent. Then the Amphicyonids began to spread across Africa and Asia. The representatives of the family who left America chose their own path of evolutionary development. They began to increase in size and switched to foot walking according to the principle that modern bears use. Their weapons were not speed and agility, but strength and a large mass. Amphicyon largely, who lived in France, Germany, and Turkey in the period from 17 to 9 million years ago, weighed about 180 to 200 kilograms. His height reached 1.7 meters. That is, in size, it was close to the largest representatives of modern cats, lions, and tigers. And the earliest Amphicyon grew to 2.5 meters in length and could weigh up to 300 kilograms. This animal lived in Europe and possibly North Africa around 16 to 24 million years ago. Dog bears, which remained in their historical homeland in North America, began to develop in a different way. Their way of moving and hunting was close to the behavior of modern large cats. That's why they looked the same. A characteristic representative of the Amphicyonid family for this area was such a predator as Diphonodon. In the period from 21 to 16 million years ago, several species of these dog bears lived on the territory of the modern United States. The largest of them had a length of about 160 centimeters, of which 70 centimeters fell to the tail. Their height did not exceed 80 centimeters, and their weight was 100 kilograms. The structure of their body suggests that Diphonodons have relied on ambush tactics or high speed in the pursuit of prey. Their limbs and their structure have common features with both panthers and wolves, along with cheetahs. These evolutionary changes, according to most scientists, were associated with the emergence of the so-called Great Plains. Huge prairies ran across the entire continent, forcing all animals to adapt to changing climate and landscape. Judging by the available data, these Amphicyonids could not reach high speed. It is unlikely that they could successfully hunt horses or deer. Most likely, tapirs and rhinoceroses, which were found in North America in large numbers, were the main prey of Diphonodons. It is reliably known that only one of the species of these predators was a pack animal, but almost all modern large predators, having common habits and structure with dog bears, are loners. Therefore, scientists suggest that large Diphonodons did not lead a flocking lifestyle. The path of development they chose eventually played a cruel joke on the Diphonodons. Approximately 19 million years ago, their larger European relatives, in the process of settling to the east, reached Siberia and the Far East. This time, they nevertheless used the land bridge across the future Bering Strait. There was a reconquest of America by dog bears. Already, after 2 to 3 million years, all local species became extinct, unable to withstand competition with larger predators. The new owners of the North American continent have occupied the niche of large predators. In their way of life, they were more like modern bears. Although they were most likely omnivores, their diet consisted mostly of meat. That is, they behaved more like white bears than brown bears. The first among the new species of American dog bears was the Amphicyon galushii. His remains, dating from 18.8 to 17.5 million years ago, were found in Nebraska. This new predator was described by Robert Hunt Jr. in 2003. At the disposal of the scientists at that time were the remains of 15 individuals of this species. Among them was a well-preserved skull, 3 jaws, some teeth, and other elements. A little later, about the same territory, such a species as the Amphicyon frendes lived. The time of existence of this large representative of the order of dog bears is determined in the range from 16 to 17.5 million years ago. His remains were first described in 1924. Later, the fossilized bones of this predator were found in other states. Described in 1988, the specimen could have weighed more than 135 kilograms during its lifetime. Similar parameters are typical for other bear dog species of this period. One of the largest representatives of the family is the Amphicyon ingens, which became extinct around 14 million years ago. According to various estimates, its maximum weight could be 220 to 550 kilograms. The body length of this predator was 2.5 meters, and the height was 120 centimeters. Of the Asian varieties of dog bears, Amphicyon paleonyticus is one of the most studied. It was discovered in 1876 by paleontologist Richard Ledecker. The remains of this animal were found in Pakistan. It is rather difficult to accurately determine the distribution area and period of existence of this Asian predator. Initially, all finds of bear dog fossils in this region were attributed exclusively to this species. In 1910, another species of dog bears, Amphicyonids ledekeri, was discovered there. It is considered the youngest species known to science that belongs to this family. Large representatives of the cat family are among the most dangerous predators on the planet. Lions, tigers, leopards, jaguars, and other cats now occupy the top rungs of the food pyramid in their natural areas. But even 10,000 years ago, they had to compete not only with representatives of other families, but also with their closest relatives, saber-toothed cats. Today, we will talk about the most interesting saber-toothed cats and the process of their transformation into the dominant predators of their time. Subscribe to the channel Age of Dinosaurs. This will allow you to be the first to know about the release of the next issue. We also encourage our subscribers to actively express their opinions in the comments under the videos. And with the help of likes, you will help promote this video according to the algorithms of the platform. That way, more viewers can see it. The idea of the saber-toothed tiger as the most feared predator of the Ice Age is largely created by various works of art. Fast and cunning cats of huge size with a short tail and huge fangs are the heroes of films, cartoons, and computer games. But at the beginning of their development, saber-toothed cats were very different from this image. The earliest representative of the cat family, which is known to science, is the Prehistoric. His name can be translated from Greek as before the cat. This animal has been distributed throughout the world. The most complete fossils have been found in France, Germany, Spain, and Mongolia. There are also several finds in North America, but at the moment, they have not been described by scientists. These great cats weighed about 9 kilograms and, most likely, led an arboreal lifestyle. Evolution to saber-toothed cats has repeatedly endowed predators with such a mechanism as enlarged upper fangs. At the same time as the Prehistoric, animals of the family of the Eurypterids, or false saber-toothed cats, lived on the earth. These predators are not even distant relatives of the modern cats, but at the same time, they have many features in common with them. Eurypterida was much larger than the Prehistoric, with growth up to 90 meters. The largest species of the family were comparable to modern lions. He lived in North America and Eurasia in the period from 13.6 to 7.6 million years ago. This beast had a large muscular body and long flattened fangs. A shadow groove ran along the entire length of the Eurypterida canine. It is believed that blood could flow freely through it when the victim was bitten. Such a peculiar tool speaks of the narrow specialization. The subfamily of the saber-toothed cats split from a common ancestor with modern felines about 25 million years ago. Then they lived exclusively in Africa. The spread of the saber-tooth in Eurasia and North America began much later. The last common ancestor of modern and saber-toothed cats is considered Pseudolure. These small animals weighing up to 30 kilograms settled all over the planet except for Australia and Antarctica. Pseudolure did not exceed modern cougars in size. The structure of its limbs says that, most likely, this predator climbed trees perfectly. In the process of their development and settlement on the planet, saber-toothed cats became larger and larger. In many regions, they have occupied the niche of the largest and most dangerous predators. Representatives of this family, who lived at the end of the Cretaceous period, are often called saber-toothed tigers. Outwardly, they did not look at all like the largest cats in Asia. Saber-toothed and ordinary tigers cannot even be distant relatives, but many scientists believed that their way of life was largely similar. For tens of millions of years, several genera of large saber-toothed cats lived in different parts of the planet. All of them had developed a muscular body with a short tail, and scientists can only guess about the color of their skins. The main weapon in the hunt for large prey was the large fangs of the upper jaw. Among them, several of the most studied and interesting varieties for researchers can be distinguished. Meganterion. Translated from Greek, the name of this large cat is translated as huge chin. Sometimes, Megatherion is also called prickly tooth. The fact that this predator cannot boast of such impressive fangs as those of its other relatives, but still, it can be attributed to the conditional category of saber-toothed tigers. The body length of the Megatherion was about 120 centimeters and weighed up to 100 kilograms. These large cats lived in Africa, Eurasia, and North America in the period from 10 million to 500,000 years ago. This means that our very distant ancestors were the prey of the Megatherions. In Africa, bones of early Australopithecus were found with bite marks from the teeth of these predators. Due to the small size of the fangs, Megatherions could hunt both large and small animals. At first, scientists assumed that these predators inflicted a swift bite at one of the critical points. They then held the victim until she bled to death or suffocated. But later studies showed that their jaw strength was not enough to hold prey for a long time. Most likely, they inflicted several sharp bites and waited for the victim to weaken. After that, they simply finished off defenseless prey. Maharod. This species of saber-toothed tiger also lived in Africa, Europe, Asia, and North America between 15 and 2 million years ago. The Maharods were steppe dwellers. Eurasia is considered their homeland. These cats owe their name to the similarity of the shape of the fangs with the curved Mahar swords that they were using in ancient Greece, Egypt, and Syria. Relatively small fangs were equipped with jagged edges. With a growth of up to 1.2 meters, Maharods could reach a mass of 220 kilograms. The Eurasian subspecies was a larger and similar in structure to modern large cats. The North American Macarods were slightly leaner and possessed elongated forelimbs. This body structure is somewhat reminiscent of hyenas. Homotherium. Saber-toothed cats from the genus Homotherium were presumably descendants of the Maharods. They appeared about 3.5 million years ago and died out about 12,000 years ago. The remains of these animals have been found not only in Africa, Eurasia, and North America. Homotherius also reached South America. Their fangs were shorter and broader than those of other saber teeth. Similar fangs of the same size to the modern Amur tiger. This means that Homotherium was capable, just like the tiger, of carrying rather large, heavy prey in its teeth for a long time. The height of this predator did not exceed 110 centimeters. His body weight reached 190 kilograms. With its physique, the Homotherium differed in many respects from the large felines we are used to. Because of the elongated forelimbs, he looked like a hyena. The structure of the pelvic bones is similar to the structure of the pelvis of bears. At the same time, the structure of the respiratory tract of the Homotherium resembles the structure of the nasal passages in cheetahs. This discovery refutes the theory that short-tailed saber-toothed cats were poor runners. But their advantage was not in speed, but in endurance. It is assumed that representatives of this subfamily were able to make long transitions or pursue their prey for a long time. Smilodon. The most recognizable of all saber-toothed tigers. It was this animal that became the prototype of one of the characters in the series of the animated films of the Ice Age. The probable ancestors of the Smilodons were the Megatherions. The remains of these large cats were found on the territory of both American continents. The earliest of them are about 2 million years old. The last Smilodons died out around 10,000 years ago. Their body length was up to 2.7 meters, height up to 1.2 meters. The body weight of these predators is estimated in the range from 160 to 400 kilograms. Some researchers suggest that the largest representatives of this genus could weigh up to 500 kilograms. The length of the fangs of the Smilodon exceeded 20 centimeters. The reconstruction of the jaws of this saber-toothed tiger showed that he could open his mouth 120 degrees, whereas modern cats can open their mouth no more than 65 degrees. Researchers are still arguing about the purpose of the saber-shaped fangs of these ancient cats. Many believe that such a highly specialized tool could have caused their extinction. Due to climate change, large herbivores, which were their main prey of the saber-toothed tigers, disappeared. Their main competitors, lions, tigers, leopards, and jaguars, turned out to be the more versatile predator. There is also an opinion that primitive hunters, with whom they had to compete for a place at the top of the food pyramid, contributed to the disappearance of the saber-toothed cats. Horses are one of the first animals domesticated by humans. All subsequent times, horses have been constant companions of people. They were harnessed to war chariots, freight carts, and passenger carts. Horses pulled the plow behind them and carried riders. Just 100 years ago, the main combat unit of any army in the world was the cavalryman. But before becoming one of man's best friends, these strong and noble animals had to go through a long evolutionary path. In addition, the horses made a long journey in order to return to their historical homeland. From our videos, you can learn many interesting facts about the origin of various animals. To be the first to know about the release of the next episode, just subscribe to the Age of Dinosaurs channel. We also encourage viewers to more actively express their opinions about our work and support the creators of the channel with likes. Horses are equid animals. In addition to them, this group also includes tapirs and rhinoceroses. They are characterized by an odd number of fingers. During the process of evolution, the middle finger of these animals gradually grew larger and turned into a hoof. This device serves to speed up running due to a smaller contact patch with the ground. Hooves appeared due to the fact that ancestors of modern horses were forced to change their place of residence and lifestyle. Ancient horses, which bore little resemblance to horses, zebras, and donkeys that we're used to, were forest animals. Climate change has led to the emergence of vast steppes. To survive, they had to adapt to new living conditions. Hyracotherium is considered the earliest known ancestor of modern equids. Also, some scientists have identified an animal such as Eurypterida into a separate genus. But according to modern classification, they are considered varieties of one creature that lived in different territories. The remains of animals found in the United States and Mexico were assigned to the genus Eurypterida. Hyracotherium also lived in Europe and Asia. The remains of Eurypterida are between 55 and 50 million years old, and the Hyracotherium settled across Eurasia several millions of years later. This means that North America can be considered the historical homeland of horses. Because the latest research says that these animals belong to the same genus, from now on we can call them Hyracotheriums. They had a height of no more than 50 centimeters and a body length of 70 centimeters. Hyracotherium weighed less than 10 kilograms. These animals most likely ate soft leaves, plant shoots, fruits, and nuts. They themselves were the prey of large carnivorous birds from the Ferraricosidae family. They had 4 toes on their front legs and 3 toes on their hind legs. On the bottom of each toe, there was a pad similar to those now found on the paws of dogs. These small animals lived in forests. Among the characteristics inherent in modern horses, one can only highlight the structure of the teeth of the Hyracotherium. Over the next 10 to 20 million years, new species of proto-horses appeared in both America, Eurasia, and Africa. They were taller than the Hyracotherium. Judging by the structure of their limbs, they could develop much greater running speed. Scientists suggest that at this time, the ancestors of horses began to leave the forests and make short forays into the steppe. Eurypterida. These still small animals were direct descendants of the Eohippus. They lived in the United States approximately 40 to 50 million years ago. Their height did not exceed 40 centimeters, but in some ways they already resembled modern horses. The legs of the Eurypterida were better suited for jumping. The shape of the skull of this animal is very similar to that of a horse, only in size it was no larger than a dog. Despite the fact that the name of this prehistoric horse translates as mountain horse, these animals never lived in the mountains. Propaliotherium. Similar animals also appeared in Europe at this time. Propaliotherium was not related to modern horses. This creature belonged to an extinct side branch of the equid order. It lived in Western Europe approximately 45 to 50 million years ago. Its height did not exceed 60 centimeters, and in some species, even 30 centimeters, and its body length was up to 50 centimeters. It weighed no more than 6 kilograms. Its legs were short, and its structure was similar, mostly to the Hyracotherium. Mesohippus. Approximately 30 to 40 million years ago, the first tridactyl horses appeared in North America. Their third finger was significantly longer than the second and fourth. When walking, Mesohippus rested only on it, but it was not yet a full-fledged hoof. On the lower part of the finger there was the same pad as the Hyracotherium or the Eurypterida. These horses were larger than their ancestors. Their height reached 60 centimeters, the body length 120 centimeters. They also had a larger skull. Their brain structure was similar to the brain of a modern horse. Mesohippus fed on plant shoots, soft leaves, and fruits. Now scientists have identified more than 10 species of Mesohippus that lived in different areas. Myohippus. Despite the name, which means Miocene horse, Myohippus appeared at the end of the Oligocene. Unlike the extinct Mesohippus, these larger horses flourished until about the middle of the Mesocene era. Their skeleton was proportionally larger than that of their ancestors. This horse already weighed 40 to 55 kilograms. By the beginning of the Oligocene, the number of forests in North America had sharply decreased. Most of the continent was covered with endless grassy plains, prairies. In the search for new habitats, the ancestors of horses began to explore the steppes. This led to major changes in their body structure. First of all, the changes affected the size as well as the structure of the legs and teeth. Only those species of odd-toed ungulates survived that were able to switch to new food, began running faster, and could notice a creeping predator in the tall grasses. Horses of this time can already be considered transitional forms from primitive species to modern ones. Epehippus. This ancient horse, also called Epehippus, they lived in North America approximately 38 to 46 million years ago. They have not yet greatly exceeded their previous species in size. Parahippus. Appearing about 20 million years ago, his height was already about 1 meter at the withers. The muzzle and legs of Parahippus became more elongated, and the lateral fingers became vestiges. Merygippus. After another 10 million years, horses began to grow and grew to about 450 kilograms. This is comparable to the mass of some modern breeds. They have seriously increased their speed movement, but the main changes were associated with the structure of the teeth and oral muscles. No wonder the name of this horse is translated as ruminant horse. By the end of the Miocene era and the beginning of the Pleistocene era, the number of equid species increased sharply. They were already very similar to modern horses. These animals were ideally suited for the life in the steppe. Among them, the following genera stood out: Protogippus, Pleogippus, Hipparion, and Gippidion. The remains of representatives of the first two genera have been found only in North America, and the Hipparions and Gippidions settled in other territories. Hipparions, which were up to 1.4 meters tall, crossed the Bering Strait approximately 11 million years ago. Their fossilized bones are found in Eurasia and Africa, and 9.5 million years ago, they appeared on the territory of the Indian Peninsula. Smaller hippopedians migrated to South America about 2.5 to 3 million years ago. But most scientists are sure that the hippoparians were a dead-end branch of development. The ancestors of modern horses could be the dinosaur Ippus or the so-called American zebra. They belong to the same genus as living horses, zebras, and donkeys. Dinohippus was also a native inhabitant of North America. This animal lived here for almost 7 million years at the junction of the Pliocene and Pleistocene era. The Hagerman's horse, or American zebra, is considered intermediate between the Miocene and more modern varieties. According to various estimates, she weighed from 110 to 385 kilograms. Her remains are found throughout almost all of North America. For unknown reasons, approximately 10,000 years ago, all equids on both American continents became extinct. This may be due to the fact that around this time, a new predator appeared there: humans. Horses reappeared in these places only after Europeans began colonizing America. And now they carried on their backs the people who had come to seize the homeland of their distant ancestors. And only a few of them stopped being pets and began being free on the expanses of the American prairies. Australopithecines are considered the most likely ancestor of modern humans. These primitive people lived on the African continent between 7 and 1 million years ago. It was they who first manifested some of the traits that were later characteristic of the genus Homo, that is, people. Scientists now know about several varieties of Australopithecines. In this issue, we will take a closer look at each of them. Australopithecines are an extinct group of the hominid family. During their development, they were upright creatures to varying degrees. Later Australopithecines had already completely switched to walking on 2 legs. It is believed that they lived in small family groups, like modern chimpanzees. The brain volume of Australopithecines was close to the brain volume of these monkeys. Their body proportions were close to those of apes such as bonobos. The height of Australopithecus did not exceed 1.5 meters. Interestingly, the average height of males was 50% greater than that of females. In modern people, this figure does not even exceed 25%. On average, men are only 6 to 10% taller than women and 15% heavier. The name of this ancient anthropoid creature simply means southern monkey. It appears thanks to the place of residence of these ancient people. They lived in areas south of the Sahara Desert. There are also later finds of the remains in North and East Africa. Like chimpanzees, Australopithecines were characterized by associations consisting mainly of males. They controlled a certain territory, protecting their females. It is believed that only young females left the family for other groups, although there is evidence of harems belonging to one male. Australopithecines had a fairly wide pelvis. This made walking on 2 legs more comfortable. It's unlikely that they were already capable of long journeys on foot, but gradually they were forced to master this method of transportation. At that time, the climate on the planet became hotter and drier. The tropical jungles and the Australopithecus habitats gave way to vast grassy plains. Upright walking became the key to their survival in new conditions. Thanks to this, evolutionary changes occurred, which ultimately led to the emergence of Homo sapiens. The ancestors of modern apes lived in more forested areas. They didn't need to walk on 2 legs a lot. The trees provided ample food and served as protection from natural enemies. Therefore, modern gorillas, chimpanzees, orangutans, and primates have developed completely different skills and structural features. Higher growth allowed our distant ancestors to notice creeping predators in time. Also, with the release of the forelimbs, it became possible to carry cubs in them or take weapons and tools. With the help of a developed thumb set to the side, it was easier and more convenient. Even chimpanzees sometimes use rocks and sticks as weapons or tools, but Australopithecus more often walked on 2 legs. Therefore, we have achieved a little more in the ability to use available tools. Later representatives of this genus may have been able to independently make primitive stone knives and wooden spears. They ate mainly fruits and nuts. There was practically no meat in their diet. Scientists divide all currently known Australopithecines into 3 groups. Early, living approximately 4 to 7 million years ago. Gracile, 2 to 4 million years ago. And massive, 1 to 2.5 million years ago. Not much is known about early Australopithecines, but based on the available findings, we can say that they are most likely candidates for the title of transitional link between apes and humans. The earliest of them is considered to be the so-called Sahelanthropus. His partial skull, dating back 6 to 7 million years, was discovered at Toros Manala in the Republic of Chad. This ancient man received the second name Tumei. In Kenya, species of early hominids have been discovered, such as Auroran, who lived here about 6 million years ago, and Australopithecus anima, whose age is approximately 4 million years. 2 more species of early Australopithecines lived in Ethiopia. Both of them belong to the genus Ardipithecus. Some remains are 5.5 million years old, others are 4.4 million years old. The height of these creatures was slightly more than 1 meter. They lived mainly in swampy and wooded areas, as well as in forest steeps. All of them were upright, but still retained the ability to climb trees. The teeth of these Australopithecines are intermediate between humans and apes. It is likely that some early Australopithecines occasionally walked on all 4 limbs. At the same time, they rested on the phalanges of the fingers. This manner of movement is characteristic of modern gorillas and chimpanzees. Some scientists have even hypothesized that Sahelanthropus and gorillas are relatives, and chimpanzees are direct descendants of Ardipithecus. We know nothing about the descendants of Australopithecus anima. Perhaps it turned out to be a dead-end branch of development and did not leave any trace in the further history of life on the planet. The gracile Australopithecines are the greatest interest to science. They are the most likely ancestors of humans. At the moment, science is leaning towards the versions of the origins of the genus people, Homo, from Australopithecus afarensis. It is the most famous and well-studied species, living in Kenya, Ethiopia, and Tanzania between 4 and 2.5 million years ago. They found skeletons of these ancient people vary greatly in size. It was probably in them that sexual dimorphism was very pronounced. The smallest skeletons are found just over 1 meter tall, and the largest are over 1.5. Their weight ranged from 30 to 55 kilograms, respectively. The structure of the pelvic bones of this creature suggests that it moved exclusively on 2 legs. His arms were still a little longer, and his legs shorter than those of modern people. The structure of the skull of the Australopithecus afarensis contained features characteristic of apes and massive Australopithecines. But he already has completely human characteristics. They also had protruding upper fangs, but these teeth are already much smaller in size than those of their ancestors. The most famous afarensis is a female named Lucy. Her skeleton was discovered in 1974. It is the most complete skeleton of the species. About 40% of the bones are preserved. It is believed that this young female died as a result of an unfortunate fall from a tree. Before Lucy's discovery, scientists had only a few femur bones and a knee joint at their disposal. One of the descendants of the Afarensis is an Australopithecus africanus. He lived in South Africa approximately 2.5 million years ago. In this structure, this species is even closer to modern humans, but he still has some monkey traits. The first and most famous discovery of the remains of this species is the so-called Child of Tong. It was a partially preserved skull of a teenager found in 1925. While studying it, Raymond Arthur Dart put forward the version that it was an upright creature. This is indicated by the anterior location of the foramen magnum. It is believed that the massive Australopithecus, or Paranthropus, and humans also descended from Australopithecus afarensis. Homo erectus appeared on the planet at the same time, approximately 2.5 million years ago. But the massive Australopithecus eventually died out about 1 million years ago, and the descendants of Erectus continued to develop successfully. With a small stature, like all Australopithecines, Paranthropus had a very massive body. For example, the most famous of them, Bayeu's Paranthropus, had a height of 1.2 meters and weighed from 40 to 90 kilograms. Also, Paranthropus apparently relied on a large skull, or more precisely, a highly developed jaw apparatus. The jaw structure is typically for animals to feed on tough plant foods, leaves, stems, and roots, but most likely ate fruits, berries, and insects like termites. They did not eat meat at all. Some scientists claim that the human branch separated from the Australopithecus much earlier. They believe that our distant ancestors developed simultaneously with the gracile Australopithecines. Whether this is true or not has not yet been definitively established. But the evolution of these primates clearly shows us how the transition to bipedal walking affected the success of their existence. Lucy and Baby of Tong may not be human ancestors, but merely cousins. But our ancestors in those days looked and lived exactly the same. We are grateful to the viewers who watched this video to the end. You can learn more about the origin of other species of people and prehistoric animals on our previous videos.